Good morning, Townview. So today we're going to talk about solutions, and we're going to start by talking about the components of solutions. Last time you guys were in here, we talked about the components. So if you already know this, there's no reason to write it down. And just know that that applies to all of our notes. If you know it, don't write it down. If you don't know it, make sure to write it down. So the name of today's unit is going to be solutions. Solutions. And what is a solute? That's the substance being dissolved. What is a solvent? That's the substance doing the dissolving. So let's say we have chocolate milk. So chocolate's being dissolved. So chocolate would be up here. And then the milk is doing the dissolving. So the milk would be down here. Usually the solvent is going to be the one that there's more of. And then the solute is going to be the one that there's less of. There are a few exceptions to this. So think about when you're making syrup. So syrup is just going to be 1 cup water for every 2 cups sugar. You're going to have more sugar in syrup than you have water, but still it's the water that's doing the dissolving, so the water would be the solvent there. Let's go ahead and move on. All right, so next thing we have is a definition. This is solubility. What is solubility? Solubility is how much solute can be dissolved under certain conditions of temperature and pressure. When we're talking about liquids, we're specifically talking about temperature. If you had to guess, do you think you can dissolve more sugar in hot water or more sugar in cold water? All right, so good guess, hot water. Pressure doesn't really matter when you're trying to dissolve a solid in a liquid, but it does matter when you're trying to dissolve a gas in a liquid. Can anyone think of examples when we dissolve gases in liquids? Say it again. Well, where's the gas? All right, so a good example would be soda. When you open a can of soda, you always hear the psh. That's because of the pressure. The increased pressure causes more of the gas molecules to actually dissolve into the liquid. So pressure matters mostly for gases. Temperature matters mostly for liquids. Also matters for gases, but we'll talk about that when we get there. All right, next up, we have 2 more definitions. First one is going to be miscible. So miscible means that these 2 liquids will dissolve into each other. An example of that's going to be alcohol and water. When you dissolve alcohol and water together, you can't see the alcohol, you can't see the water because they become one thing. So that's a miscible, that's considered miscible. Immiscible is going to be 2 things that will not dissolve into each other. The best example of that is going to be oil and water. Oil and water will not dissolve into each other. They're just going to form 2 distinct layers. We're not going to talk about specifically why they do that. You just need to know that 2 liquids that cannot dissolve into each other are called immiscible. Where 2 liquids that do dissolve into each other, those are miscible. These are 2 definitions. You absolutely need to know them. We'll give you a couple more seconds. All right, let's move on. So next up we have factors affecting solubility. So the first one, actually I want to see if y'all can come up with this. So factors affecting solubility. What do you think are ways we can make something dissolve into something else more rapidly? So let's say we're talking about sugar and water. What are some ways we can make it dissolve more quickly? All right, so I heard stirring. What you got in the back? Putting it on a stove, so heating it up. Can y'all think of any more? All right, so if you had a sugar cube and you had powdered sugar, which one do you think will dissolve more quickly? Why the powder? What is it? Why the powder? All right, so let's go ahead and talk about it. So the first factor that affects solubility is surface area. So the amount of surface area that's exposed to the liquid. So when you're dealing with a sugar cube, only the external surface, only the outside surface is being exposed to the water at a time. Once it dissolves, then the surface below gets exposed. But if you were dealing with powdered sugar, it's almost all exposed at the same time. So the powder is just going to dissolve much more rapidly. So That's so the first factor that affects solubility is surface area. Crushing a sugar cube will cause it to dissolve more quickly. So use mortar and pestle. That's not, you don't really need to write that. What you want to know is that the surface area, so more solvent contact, the more surface area contact that there is, the faster it'll dissolve. All right, so the next one is going to be agitation or stirring. You need to know what agitation means. That means either shaking or stirring, because it's very unlikely you'll see stirring on the ACP. You're going to see agitation instead. So if you stir it, that's going to make it dissolve more quickly. This only applies to liquids and solids, though. So this applies to liquids and solids. If you stir a gas, it will not dissolve more quickly. So stirring a gas in a liquid will actually cause it to come out of the solution. So with a gas, you don't want to stir, you don't want to shake. So just think about when you shake a can of soda, what happens to the CO2 that's in the liquid? It escapes, and that's why it increases the pressure of the can. All right, let's move on. So the next one is going to be the temperature of the solvent. And you guys already said this, so a hotter liquid is going to dissolve more solid into it. That's absolutely true when we're talking about liquids and solids. So heating up the liquid will cause it to absorb more solid. This does not apply to gases, though. We'll talk about gases on the next page. So higher temperature will allow more solid solutes to dissolve. All right, let's move on. So when we're talking about gases dissolve better when the solvent temperature is colder. That's why you don't want to drink warm soda. It's not the only reason, but a warm soda is going to go flat much more rapidly. That's why keeping your soda cold will keep it fizzy. So gases, they dissolve better when the solvent temperature is cold. That's the opposite of solids. All right, let's move on to the next one. So the next one is pressure. Pressure only affects gas solubility. So take a look at this image right here. We have the same amount of water in both of them. But what we're doing is we're compressing it. So we're forcing more of these gas molecules into the liquid. So down here we have 6 gas molecules in the liquid, where here we have 9 gas molecules in the liquid. And that happened just because we increased the pressure. So increasing the pressure causes gases to dissolve into liquids. That's why all sodas are pressurized. And after you open up a soda and it loses that pressure, it becomes more flat more quickly. Does anybody here open sodas and put them in the fridge because they like them flat? That's nasty. No, I got you. It makes sense. All right, let's move on. So this next slide, we've already talked about the nature of solute and solvent. Polar solutes dissolve polar solvents. Nonpolar solutes dissolve nonpolar solvents. And all you need to write here is like dissolves like. That's why polar bears dissolve in water. All right, so real quick, I want to show y'all a simulation. So this simulation, you're not gonna have to, you're not gonna get to play with it, but I do want to show you this thing right here. So we have some solid drink mix. Let's make it potassium chromate. So we're gonna put in this potassium chromate in water, and we're gonna keep adding it until we can't add any more. So we're gonna keep going, and now it says saturated. You guys aren't familiar with saturated. We haven't talked about what saturated means yet, but that's the next definition I want you guys to write. So write saturated, and the definition for saturated is that's when the liquid can no longer hold any more solid. So if a liquid is saturated, that means you can't put any more solid in it. So take a look. I'm going to remove this and do it again because I added way too much. Bless you. All right, we've reached saturation. So once it's saturated, I continue adding. What happens? So take a look. What happens when I add more? Does the color change? I'm going to put the concentration meter here to give us the concentration. Does the concentration change? Why? Because the solid is what? Because the solid isn't dissolving anymore. What's one thing I can do to get rid of some of this solid at the bottom? Say it again. So we're going to add more water, and as I do that, you see how it's going away at the bottom? And now we've reached the point where it's not saturated anymore. And what that means is I can add more solid now. So we're going to add a little more solid. And then here we are, we're saturated again. We can add more. And that's what I wanted to show you guys. So our definition, the first one that you guys just wrote down, should be saturated. That means it can't hold any more solid. There's one thing I wanted to show y'all. Forgot. All right, so we're saturated already. If I were to switch this, oh, it won't let me. But if I were to switch it to something else, what I want you to know is it's still not going to take any more of the new stuff. Because the water is fully saturated, you can add anything. It's all going to fall to the bottom because the water can't hold any more solid. Not just one type of solid. It can't hold any more solid. So that's what saturated means. The next definition is unsaturated. What does unsaturated mean? What does unsaturated mean? It can hold more solid. Now the last one is going to be supersaturated, and we're going to talk about supersaturated in a little bit. But supersaturated, that's when you increase the temperature to make it hold more solid. So sugar, if you add sugar to water, at some point the sugar is going to start falling to the bottom and not dissolving in the solution. But if you increase the temperature of the water, you're going to dissolve more of that solid. That's why syrup, you need to make syrup on a stove. You can't make syrup without heating up the water because that's a supersaturated solution. But one other thing I want to talk about is honey. Everybody here has honey in their cabinet. What happens to honey after it sits in your cabinet for a couple months? What separates? All right, so what happens is sugar falls out of the solution. So supersaturated solutions, they don't stay supersaturated forever. They hold a lot more solute than they can for a while, but eventually that solute falls out of the solution. So over here, that's what you're seeing in this right here. For those of you who took a look at it, y'all see that solid? That's solid that fell out of the solution. So it couldn't hold any more solid, so this is called a precipitate, and it fell out of the solution. Well, let's show it to Wolf's class. So that's a precipitate that fell out of the solution. Supersaturated holds more solute than it normally would at a given temperature. Another example of a supersaturated solution is going to be soda. So the reason soda tastes so strong is because it's got so much sugar in it, and soda is a supersaturated solution. All right, let's move on. So this one is just meant to tell you that once it becomes saturated, you can't add any more other stuff. So if we add as much sugar as we can to water, and then it starts falling to the bottom, if we start adding salt, all the salt that we add in is going to fall to the bottom. It's not going to dissolve. You can't dissolve any more other stuff. So once it reaches saturation, you can't add anything else. All right, let's move on. So the next thing I want to talk about are electrolytes. So can anyone tell me how your brain communicates with the rest of your body? How does your brain tell your arm to go up? How does it tell you to stand? How does your brain communicate with your body? All right, that was fast. Health students, they know what's up. So your body, your brain communicates with your body using electrical signals. So anybody know what Gatorade is filled with? Electrolytes. What are electrolytes? They're not electricity. What are electrolytes? Why do athletes need so much electrolytes? Well, say it again. It's not energy. So has anybody ever tasted their own sweat? What does sweat taste like? It's salty. So when you sweat, you're releasing a lot of salt. And athletes, they sweat a lot, so they sweat out a lot of salt. And you need salt in your body so that your brain can communicate with the rest of your body. So if you don't have salt, your brain can't tell your body what to do. If you go a week without any salt, your body won't function anymore. Lucky for you guys, everything has a ton of salt in it. So athletes, they drink electrolytes while they play to rehydrate their electrolytes, their salt that's being released from their body as sweat. So what I'm about to show y'all right now is something regarding electrocution. I want to see if I can show this to Wolf's class as well. So let's see. All right, so who here has a blow dryer? All right, most of y'all have a blow dryer. There's a tag at the end of your blow dryer. What does it say on it? You ripped it off? What's the wording? Anybody read it? Say it again. All right, so it says something along the lines of do not use in your bathtub. Because for some reason, some people like to blow dry their hair while they're in the bathtub. So why do y'all think it says that? Why can't you use your blow dryer in the bathtub? It is America. It's a free country. Why can't you use your blow dryer in the bathtub? Say it again. So what's the problem? Is it the blow dryer or is it something else? It's the water, right? What about water? So water conducts electricity, right? So does all water conduct electricity? Does all water conduct electricity? So here we have some tap water. And right now I have this light bulb right here. It's connected to power, and it's receiving a negative signal. The positive signal is going through one side, and the only way to get power is if we can send the signal from this side over to this side. Now there's two ways to do that. We could either run a wire from the middle of this one to that one, and the light bulb will turn on. But we're gonna run it through water to see if water will conduct electricity. This water came from the sink. Is this pure water? What does it have in it? It's gonna have some salt. It's gonna have some minerals, and let's see if it causes the light bulb to turn on. All right. So this light bulb didn't turn on. Let me see. This is not the one I want to use. Let's switch over to the energy efficient light bulb. This light bulb needs way too much power when she comes back. So we're going to run this energy efficient bulb. This one requires less power to run, so it's more likely to turn on in any condition. All right, so tap water, we're running an electrical signal through it. Do y'all see the flickering? Those of you who are in the camera, y'all probably don't see the flickering, but y'all in the front, do y'all see the flickering? Yeah. So what does that mean? Is the water conducting electricity? Is it conducting electricity well? It's not conducting electricity well. When people take baths, though, do they bathe in just regular water? What do they put in their bath?
Soap.
Some people use soap. Some people use salt. And salt is the ultimate conductor of electricity. So here I have some salt water. This is extremely salty water. You do not want to drink this. Super, super salty. We're just going to put some in. So does water conduct electricity? Are you sure?
No.
What conducts electricity? Salts conduct electricity. So when you put salts in water, what they do is they dissociate into ions, positive and negative ions, and those allow the electricity to actually transfer. Now there's one more thing I want to show you guys. So we're going to pour out this salty water, and we're going to put in some water again, fresh water. And I want to leave some room so that I can pour in some additional solution. So I want to show you all the difference between the 0.6 molar solution that we had earlier. So this one right here, the 0.02 molar. And I'm going to pour in some of this. Did y'all see how much I put in? I put in a lot. Is there much of a difference? No, there's not. So this one right here, I hardly have any left. Basically just going to put in a few drops. Because I put in less, this one requires a little bit of stirring. So let's give it a stir. Let's give it a better stir. All right, I think it just wants a little bit more. Let's put in a tad more. So do y'all see the difference between 6 molar and 0.02 molar? I put in a lot of this, and y'all didn't see anything. I put in just a few drops of this one, and we got the light bulb turning on all the way to the very top. This tells you the difference in concentration. So this one is much more concentrated than this one. Now there's one more thing I want to show you. So we're going to pour out this slightly basic solution. We'll pour it here. Just because I want to neutralize it before I pour it down the sink. You don't want to pour acid or base down the sink. All right, so the first time I did it, I showed y'all that when you put in a salt, it conducts electricity. This time we're going to pour in a little bit of acid. This one's not a very concentrated acid, which is why I pour in a lot more of it. Anybody want to touch the water? You don't want to touch the water. So this is 120 volts. Anybody know what happens when you touch high voltage current? It doesn't just shock you. It actually grabs you, and it won't let you let go of it. You'll be stuck. That's the big problem with so the U.S., we run 120 volts. If you've been to Mexico, you know Mexico runs 240 volts. Their power is much more powerful than ours. If you get electrocuted there, it like blows you up against the wall. You usually survive that. It hurts a lot, but you usually survive it. Our 120, that one grabs you, and it won't let you go until you're fried. So just be weary.
Don't you have to like put your hand like that?
Say it again.
You know how like the electric fences? People touch it like the back of their hand.
I don't suggest you touch electric fences. I don't know about your friends. All right, so that's it for the demo. Let's go ahead and continue on. Oh, and there's one more video I want to show you guys. Have I ever shown y'all the dancing squid video? All right, so take a look.
Teachers for this interruption. All juniors participating in the Texas Scholars College Fair, please report to the front of the school near the stairs. Once again, all students participating in the Texas Scholars College Fair, please report to the front of the school near the stairs. Thank you.
All right, so does this squid have a brain? No, it don't. Why is it moving? Because they're pouring salt on it, and salt conducts electricity, and that's what you're seeing there. It's not being electrocuted, no, but the energy that's left in its nerves is being utilized. It's getting signals the same way its brain would send its body signals, and it's causing it to move. That's what salts do. If you've ever been to a farm and you saw the cows, what do cows always have nearby? Y'all don't know? Here, I'll show y'all. So this right here is cow salt. And there's not a lot of salt in the grass that they eat. So they have to, farmers always have to place salt for the cows. They need it or else their body stops functioning. So all farm animals are going to have a brick of salt that they just lick on whenever they feel like it. And they love it. They love the salt. All right, let's move on. My uncle had one of these, and the cows would stick their tongue in this hole, and then they love the salt. All right, let's go ahead and move on. All right, so next up, electrolytes. What are electrolytes? What are electrolytes? They're anything that conduct electricity when dissolved in water. So electrolytes are anything that conduct electricity when dissolved in water. If they don't conduct electricity when dissolved in water, they're not electrolytes. Another thing to know about electrolytes is that they dissociate in solution. Let me get the spelling for that word so Wolf's class don't laugh at me. All right, so dissociate, that's when you have something like salt. So NaCl is sodium chloride. It's an ionic compound. When we put sodium chloride in water, what we get is Na+, which has a charge, that's an ion, and we also get Cl-. So that's what dissociation is. Anything that breaks apart to form ions in solution, this will also conduct electricity. So salts do this. These are ionic compounds. Acids also do this. Acids will, like HCl. So HCl is going to form H+ and Cl-. Or bases, like NaOH, which is going to form Na+ and OH-. So salts, which are ionic compounds, will dissociate to form electrolytes. Acids will dissociate to form electrolytes. And bases will dissociate to form electrolytes. So these are all things that are electrolytes. Acids, bases, and salts are all electrolytes. Notice how I didn't say sugar. Sugar will not conduct electricity. All right, I'm gonna need to wash my hand. I think I got some base on it. All right, so let's keep going. So why do they conduct electricity? Because they create mobile ions in solution. We talked about that on the previous slide. So something like NaCl is going to create Na+, that's an ion, and then Cl-, that's also an ion. HCl, that's going to form H+ and Cl-, these are both ions, and then Na+, OH-, that's another ion. So anything that creates ions in solution will conduct electricity. And the more concentrated it is, the more it'll conduct electricity. That's what you guys saw with in the demo, how the highly concentrated sodium hydroxide, it caused the light to go way brighter. All right, let's go ahead and move on. We're not going to spend much time here. So the next slide is going to have some examples for you. So here it's just asking you, will this thing conduct electricity? You're going to see a question like this on the test. So will it conduct electricity? If it's an ionic salt, then yes, it will. If it's an acid, then yes, it will. If it's a base, then yes, it will. So over here, we have glucose. Is glucose an ionic? Is it an ionic compound? Why not? It doesn't have a what? What is an ionic compound? Ionic is going to be a metal plus a non-metal. So do you see a metal in C6H12O6? Is it ionic? No, it's not. Is it an acid? What do acids start with? So acids start with H. This is not an acid. Is it a base? What do bases end in? So acids, I'll put these for you. Acids start with H. Bases end in OH. So that's how you identify if it's an acid or a base. So is C6H12O6 a base? Does it have OH? And by OH, I mean hydroxide. I don't mean hydrogen and oxygen. Does it have a hydroxide? No, it doesn't. So will this conduct electricity? No, this one will not. The next one, is it ionic? If it's ionic, what's going to happen is when you put it in water, it's going to give you Li plus and Br minus. So will it conduct electricity? Yes. Next one is potassium hydroxide. What is potassium hydroxide? This is a base. When you put a base in a solution, it's going to give you K plus and OH minus. Will it conduct electricity? Yes. The next one is CH4. Is it ionic? Is it an acid? Is it a base? Will it conduct electricity? No, it will not. Next one is H2SO4. Is it ionic? Is it an acid? Is it an acid? Yes, it is. So this is going to give us H plus and HSO4. So this will conduct electricity. The next one is NO2. Is it ionic? Is it an acid? Is it a base? So this will not conduct electricity. Was that easy? You're going to get more practice once we take our quiz on everything that we've been doing, all this new stuff. All right, let's move on. So next up, we got this solubility curve. Let me fix this a little bit so that it looks better for you guys. So we already talked about what solubility is. So what is solubility? What is solubility? A little bit louder. What is solubility? All right, it's the amount that you can dissolve at a given temperature. So over here, what we have is 100 grams of water. And what they're telling you is how much KNO3 we can dissolve in this water based on different temperatures. So at 0 degrees C, we can dissolve about 8 grams. At 10 degrees C, we can dissolve about 10 grams. At 20 degrees C, we can dissolve about 15 grams. At 30, it's about 22 grams. And you can see that this increases as we increase our temperature. So here's what I want y'all to know. We already talked about saturated, unsaturated, and supersaturated. But let's say we have a 40 degree solution of water, and we put in 20 grams of potassium nitrate. Is this a saturated solution? Yes or no? Does it have as much as it can take? Yes or no? Does it have as much potassium nitrate as it can take? No, right? How much can we put at 40 degrees? It's going to be at this line, right? It's going to be right here. About 38 grams. So if we only put in 20 grams, what kind of solution is this? Saturated, unsaturated, or supersaturated? Say it again. All right, unsaturated. So what you need to know is anything underneath the curve, that's going to be unsaturated. What I would do if I were you is I would draw a little chart, I would put a line on it, and then I would label the parts. So underneath the line, that's going to be unsaturated. What about on the line? What's on the line going to be? On the line is going to be saturated. All right, now here's where it gets messy. This is where students mess up the most. So if I told you that I have a 30-degree solution of water and I dissolved 50 grams into that water, what kind of solution would that be? So I have 100 grams of water at 30 degrees Celsius, and I dissolve 50 grams into it. What kind of solution would that be? It would be supersaturated. But what if I just put 50 grams in it? Would it be supersaturated? What do you need to create a supersaturated solution? What do you have to do to the temperature to dissolve it? You have to heat it up, right? So if I put 50 grams in water, they're not going to all dissolve. If I heat up the water, then they're all going to dissolve. So you have to make sure you're reading the question correctly. But above the line is going to be supersaturated sometimes. So sometimes it's supersaturated, sometimes it's just saturated. So if I put sugar in a cup of water until it can't hold anymore, and then I just keep adding more sugar, it's only a saturated solution. The only way to make it a supersaturated solution is to heat it up and then get it all dissolved into it. Any questions about that? All right, let me pause the video real quick. All right, so let's start by looking at the back page. Appreciate it. All right, so let's take a look at, let's start with potassium iodide. So here's potassium iodide right here. At 0 degrees, we can dissolve 125 grams. At 10 degrees, we dissolve 135 grams. At 30 degrees, we dissolve about 144 grams. Is this a solid or a gas? We're able to dissolve more as we increase temperature. Is this a solid or a gas?
Solid.
It's a solid. If the line goes up, this is a solid. Over here, we have hydrochloric acid. So hydrochloric acid comes in many forms. You can get it as a solid, a liquid, or a gas. But over here, what we're seeing is as we increase the temperature, it's dissolving less into the solution. So what type are we dealing with here? So this one right here is a gas. So if the line goes downward like this, that's a gas. All right, let's take a look at our questions. Look at the table above. For most materials, how does temperature affect solubility? So looking at the chart, how does temperature affect solubility for most of these? It increases. All right, there are 4 compounds listed that don't follow the general trend. What are they? Which ones don't follow the general trend? All right, a little bit louder, please. Which ones don't follow the general trend? I'll help you out. SO2? What's another one? NH3? What's another one? What's another one? It's Na2SO4. So even though this one's a solid, or no, this one right here. Even though this one's a solid, there are exceptions to the rule. And this one, as you increase temperature, it's less soluble. So 3 compounds identified above are gases. The hydrogen chloride is soluble enough in water. All right, so don't worry about number 3. Let's just move on to number 4. So look at the curves and see how many grams of NH4Cl could dissolve in 100 grams of water at 50 degrees Celsius. So we're looking for NH4Cl. NH4Cl is right here. It's this one. And we're looking at 50 degrees C. So at 50 degrees C, how many grams can we dissolve? So 50 grams. How much in grams if you use 300 milliliters or 300 grams of water? So all of these are for 100 grams of water. If we had 300 grams of water, how much can we dissolve? What is it? It's going to be 150. We're just going to multiply by 3. So 150 grams. How much if you used 100 grams of water but heated the water to 80 degrees C? So this time we just moved to 80 degrees C. And what's our answer? It's going to be right here at 65 grams. How many grams of sodium nitrate can dissolve in 100 milliliters of water at 70 degrees C? So NaNO3 is right here. And we're looking at 70 degrees C. So here's 70 right here. What is it? I heard 135. And then it's also asking at 10 degrees. What's 10 degrees? What's 10 degrees? All right, so about 79 grams. A solution of NaNO3 in 100 grams of water is saturated at 40 degrees C. If it's cooled to 10 degrees, how much precipitate forms? So to answer this question, you need to know what a precipitate is. A precipitate is anything that falls out of the solution. So we know that we can dissolve, we're looking at NaNO3, and we're starting at 40 degrees. So we have a saturated solution. That means it has about 102 grams dissolved in it. If we cool it down to 10 degrees, 10 degrees is going to be 79. How much is going to fall out of the solution? If we start with a saturated solution at 40 degrees C, and then we cool it to 10 degrees C, how much is going to fall out of the solution? So the answer is this right here. All of this is going to fall out of the solution. How much is that? It's going to be 23 grams. So precipitate, this is what falls out of the solution. So right here, what I showed you earlier, that cloudy stuff that fell out of solution, that's a precipitate. Rain is precipitation because it falls out of the clouds because the clouds don't want to hold that rain anymore. At what temperature do KClO and NaCl have the same solubility in water? So KCl and NaCl, here's KCl right here. Here's NaCl right here. And they have the same solubility at about 33 degrees Celsius. If 200 grams of water is saturated with KCl at 10 degrees, how much more can be added and still dissolve if the solution is heated to 70 degrees? So we're looking at KCl. Here's KCl right here. And we're going from 10 degrees, that's right here at 30. So we're going from 30 all the way to 70 degrees. 70 degrees is right here. And that looks like it's about 48. So 30 all the way to 48. So how much more can we add to the solution? How many grams? How many grams are we adding? 18 grams. How many grams of NaNO3 are required to saturate 400 grams of water at 10 degrees C? So NaNO3 is right here. And for 100 grams of water at 10 degrees, we can dissolve 79 grams. So if we're trying to saturate 400 grams, what do we got to do? What do we multiply by? We multiply by 4. So 79 times 4, what does that give you? All right, so it's 320 minus 4, which is 316 grams. What is the smallest mass of water that can completely dissolve 23 grams of NH4Cl at 40 degrees C? So we're gonna look for NH4Cl. NH4Cl is right here, and we're at 40 degrees C, which means we're right here. And with 100 grams of water, we can dissolve about 46 grams. So to dissolve 23 grams, how much water do we need? What is it? Say it again. So we can dissolve 46 grams in 100 grams of water. How much water do we need to dissolve 23 grams? It's going to be 50 grams of water. Last one, what is the mass of water for 100 grams at 40 degrees C? That one's just going to be the 46. All right, any questions? All right, so I just solved one side with you. The other side, that's the one that you need to do. It's going to be due next class. We'll see how much of it you can get done on your own. Good luck, and that's it. Have a good day.